Student, today I discuss about the brief construction and operating principle on the three-phase transformer. Here, three single-phase type transformer connected with their yokes 120 degree apart from each other. The primary and secondary windings wound over the limb number 1, limb number 2, limb number 3, and other limbs are unwound and brought contact. Okay, so the system look like this. Now the phase current in the primaries produce three-phase flux, that is 120 degree apart. Now flux flow through their respective limbs as well as in the center limbs. Flux flow through their respective limbs and as well as through the center limbs. The resultant Phasor sum of flux in center limb should be equal to 0. As you know, the resultant flux phi equal to sin omega t plus sin omega t minus 120 degree plus sin omega t minus 240 degree. So if you calculate this should be equal to 0. As the flux in the center limb is equal to 0, so this center limb can be eliminated. So as now transformer looks like this is your one limb, this is another limb, and this one is another limb. So this type of construction is very costly. As we eliminate this type of frame construction is very costly. So we construct this, the code type three-phase transformer. This is shown in figure number 2. So flux produced by one legs will return through the another two legs. Similarly, as you know, in case of three-phase system where current is one wire, at any instant is returned through the other two wire. So look at the picture that in center number 2 has low reluctance offered on the system compared to the link number 1 and link number 2. So there is very small difference of exciting current that have no effect on the core material selection. This one is the cell type three-phase transformer. Here three single phase cell type transformer connected side by side. So we are draw the flux rotation, that is phi A, this is phi B, this is phi C. Okay. Then the system resultant flux, suppose we are marking here 2, that should be equal to the flux, resultant flux difference of phi A by 2 and phi B by 2. Okay, this one is shown in this diagram, that is phi A 120 degree apart, this is the phi B, and another 120 degree apart, this is the phi C. Okay, now in mark position 2, the resultant flux should be phi A by 2 minus phi B by 2. So that should be equal to, that is, suppose phi 2, that should be equal to phi A by 2 minus phi B by 2. Now we are taking the phi A here as a reference. Okay, so phi 2 is equal to half phi 0 degree minus phi minus 120 degree. Okay, so that should be equal to half phi into cos of 120 degree minus j sin 120 degree. Okay, so this is equal to phi by 2 3 by 2 plus j root 3 by 2. Now the magnitude of phi 2, that should be equal to, this one is the magnitude of phi 2 is phi 2 by 2 root over 3 by 2 whole square plus root 3 by 2 whole square. So that should be equal to root 3 by 2 phi. And if you calculate the similar process in case of 3 segment, that should be equal to, that is phi 3, that should be equal to root 3 by 2 of phi. So look at this two equation, phi 2 and phi 3. So the same flux density, the cross-sectional area at segment 2 and segment 3 are root 3 by 2 times, that is 86.6% of the central core area, where flux phi is, that is equal to phi A equal to phi B equal to phi C. Again, in section 1 and section number 4, the flux is phi by 2 in section 1, and 2 flux is phi by 2. So their area is 50% of central core area. So area at 1 and 2 is 50% of central core area. The area in 2 and 3 are 1.732 times of the area 1 and 2. Now if the winding B is wound in reverse direction, if the winding B is wound in reverse direction, the what should be the value of phi 2 and phi 3. Now winding is wound at reverse direction, so the phi 2 is, from this phasor diagram, phi 2 is phi a by 2 plus phi b by 2. Okay. Now the phi 2, taking phi is the reference, phi a is the reference, so half phi 0 degree plus phi minus 120 degree. So if you calculate, the phi 2 is phi by 2 root over half square plus root 3 by 2 square. So this magnitude is only phi by 2. Similarly, the phi 3 in section 3 is again phi by 2. So if you reverse the direction of winding B, the flux in the segment 2 and segment 3 is phi by 2 and phi by 2. Thus, while the winding B is wound in reverse direction, the area of construction in Mark 1, Mark 2, Mark 3 and Mark 4 are same, and it is equal to 1/2 of the central limb. So area of 2, 1, 2, 3, 4 are equal, and it is half of the central limb area if the winding B is wound in reverse direction. So this type of construction, when B is wound reverse direction, that is more effective than the when is wound in similar pattern, when is wound in same direction in A, B, C. So this is most economical when winding B is wound in reverse direction. So student, these are the structure and operating principle of three-phase code type and cell type transformer. If you have any query, please contact me. Thank you.